So now we are coming on second lecture, that is showing the circular system, third system which we have in our measurement part, that is the circular system. And in this case, the angle which you are going to measure will be in terms of radian. That angle will be in terms of radian, R-A-D-I-A-N, radian we have. First, we define what is 1 radian. What 1 radian says that if you draw any circle, radius is your choice, you take it, no problem. Let the radius of this circle is R. Any circle you draw with any radius, and because this whole part is depending on circle, that's why I also called as circular system. All the definition in this case will be depending on circle. So we have taken one circle with radius R. And now if I take arc of this circle, I'm taking the arc starting from this point. Let this point is P. This is the origin. And from P to Q. This arc I am taking now. This arc I am taking such a way that the length of this arc is also equal to radius. Okay. Whatever the length of this and whatever the length of this will be same. And if you say how you calculate the length, you take the thread you put on this circumference. Then you straight it and find out what this length comes. That length must be same as the length of, that is the radius of the circle. And then if I join O to Q, then what this angle comes out to be called as 1 radian, denoted by 1 C. C stands for circular system. So it will be 1 C, or it is called as 1 radian. So 1 radian is what angle? This is the angle subtended. You can write it, angle subtended by an arc. By an arc of a circle. I just repeat it. 1 radian is that angle which is angle subtended by an arc whose length is equal to the radius of the circle at the center of the circle. At the center of the circle, if the angle we are taking which is formed by an arc whose length is same as the radius, means if I say it is 2 centimeter, it should be 2 centimeter. If it is 3, it should be 3 centimeter. If it is 4, it should be 4 centimeter. Then whatever this angle comes out to be called as 1 radian. So 1 radian is what angle? Angle subtended. By an arc whose length is equal to radius of circle at its center is 1 radian. So angle subtended by an arc whose length is equal to the radius of the circle at the center or at its center is called as 1 radian. So 1 radian you should keep in mind. This is the angle subtended by an arc whose length should be equal to the radius of the circle. By the way, this arc has length 2r. This length is 2r. Then how much angle it will be? Then this angle will become as 2 radian. Because this is twice the length of arc, then the angle will become 2 radian. So this way the radian we will be going to calculate. 1 radian means the length of arc should be same as the radius. If twice radian means twice the length of the radius will be the length of the arc, then whatever the angle subtended at the center, we call that as 1 radian, 2 radian, 3 radian. Now one more thing you should keep in mind here. Radian will be a constant value. 1 radian is constant. Just like 1 degree is constant, 1 radian is also constant. It is not depending on the radius of the circle. Why it is not depending? Just check. If you take this circle, if you take another circle here, one thing we have done already, that angle subtended at the center of any circle is proportional to its arc. If you say this part, let this length be 2 centimeter, and I'm taking this as 2 centimeter. Then when you solve, you take the another circle, let the radius of this will be 4 centimeter. Then automatically you will find that if this is 2 equal to the radius, this will also come out to be the radius 4 centimeter. That means if you consider this circle, this is the length of arc equal to radius. So this angle is 1 radian. Here in this case, in the second circle, when the radius is 4 centimeter, at the same time you will find this arc length will also become 4 centimeter. Because this arc length depends on is proportional to the radius of the circle. So as you take bigger circle, automatically this part will become bigger. But the angle is not going to change at all. If you take third angle, in the same proportion as the radius is going to change, in the same proportion this is going to change. For example, if it is 6, then you will find this is come out to be 6. So every time how much is the angle? Angle will remain 1 radian. So radian is always a constant quantity, you should keep in mind. So 1 radian is the angle subtended by an arc on the center of the circle when the length of the arc is what? Length of the arc is same as the radius of the circle. So that you should keep in mind. This is the definition of 1 radian. And now one more thing I'll show, that 1 radian is a constant value. I'll tell that also. So we'll do next now. So now I'm finding that, or we are proving that radian is a constant angle. So next we are continuing radian as a constant angle. Yes, now coming on next result, which I told that radian is a constant angle, 1 radian is a constant angle. One method I told you how to do it when we just increase the radius, that was clearly visible. Now we'll prove it also. So here in this case, what we have first, I have taken a circle. Let the radius of the circle is r. OA is the radius. Then A to P, we have taken the arc of the circle and whose length is same as the radius. So this is r, then this is also r. Then automatically this angle come out to be 1 radian. Now I do one thing, I'll extend AO to B. This is a straight line, I am extending AO, we are extending till B. We join it till this here. And now if I just go on angle AOP, angle AOP, if I take, it is clearly 1 radian because this is the angle subtended by an arc which is length equal to the radius. Second one is angle AOB, that is this angle. This is a straight line angle. It is come out to be what it is, 2 right angle. So we have first taken this angle as 1 radian, then I have extended this line, then automatically this whole angle come out to be 2 right angle. This part we have done. Now we have one theorem. Since the angle at the center is proportional to the length of arc, means if you have arc length less, angle will be less. If the arc length is more, the angle will be more, and in same proportion it is going to change. So that means what I am having here, angle AOP by angle AOB, whatever the ratio of these two angles will be same as the ratio of their arcs. As I told you, angle at the center is proportional to the length of arc. Means if smaller the angle, smaller the arc. Smaller the greater the angle, greater the arc. So here we will say first time if I am taking 1 radian, arc length is only AP. When you are taking 2 right angle, the arc length will be APB complete. So we will say angle AOP by angle AOB is equal to. What this will come out to be? AOP, the arc length is what? Arc AP divided by arc APB. So whatever the ratio of these arc will be the ratio of these angle. Whatever the ratio between this angle and this total angle will be same as this angle to this total. So I got this angle AOP by angle AOP is the arc AP by arc APB. Arc AP is same as the radius, nothing wrong in it. Arc APB is what? Is it half of the circumference? So is it pi r? Yes. AOP is how much? This is 1 radian. By angle AOB, will it be 2 right angles? Yes. So 1 radian by 2 right angle is 1 by pi now. And as you get this, what I get here, 1 radian is equal to 1 by pi into 2 right angle. This is a constant number, 2 right angle. This angle can never change. 2 right angle means 180 degree, you know it. It is not going to change. Same way, pi is also a constant number. You can't say that 2 right angle will be going to change if the radius of the circle is going to change. No, this angle always come out to be 180. If you take the bigger circle, again the angle come out to be 180. So this is not going to change. So 2 right angle is a constant value, pi is a constant value. So that means this is come out to be constant. So 1 radian is equal to constant. That you should know. So 1 radian is a constant angle. We should know this. Okay, now we are generating a formula in which we are calculating angle in terms of radian. How we are going to calculate angle in terms of radian, that we should find out. So we have a formula. Now we are going to create a formula for angle in terms of radian. So whenever you want to calculate the angle in terms of radian, what formula we can use, we are going to generate this. So again we are going on the same circle. This is OA is the radius of the circle. AP will be the small r, that is the radius of the circle. So automatically this angle will be 1 radian because the length of arc is equal to the radius, then angle subtended is 1 radian. Now I'll extend this P to Q. Then in that case, let this angle come out to be theta radian. We should calculate what this theta radian will be. I know this is 1 radian, but what is this angle theta radian, we should find out. So in this case, again we will use this result which we have done in the previous theorem, or one result I told you, angle subtended at the center is proportional to its arc. That means angle AOP by angle AOQ will be equal to, this is arc AP by arc AQ. So this is the formula you should remember. Angle AOP by angle AOQ will be arc AP by arc AQ. Angle AOP is already known as 1 radian. Angle AOQ we want to calculate. Arc length of AP is small r. Okay, and this is come out to be arc AQ. Clear or no? Then we want angle AOQ to be calculated. So this term I'll take this side. Angle AOQ will be what? R by arc AQ. AOQ will go this side. So this will be opposite now. AOQ will go this side. So it will be arc AQ into 1 radian divided by r. 1 radian is a constant value in terms of radian it is. So 1 radian, and this is arc length. So what it will come? Arc AQ by the radius. This is angle AOQ, and this angle will come in terms of radian because this is coming in radian, so this will also be in radian. So angle AOQ, if you want to take, this is coming equal to what? Arc AQ by the arc. Angle AOQ, that is this angle, it is in terms of radian if you want. What it will be coming? This arc length by the radius. So angle, whenever you want to calculate in terms of radian, now I got a direct formula. Angle in radian is equal to arc, that is arc of this angle divided by the radius. So whenever you want to calculate angle in terms of radian, we will be having formula arc by the radius. You should know, if I want this angle to be calculated in terms of radian, then I should know what is the length of this arc and what is the radius of this circle. If these two I know, then I can calculate angle in terms of radian is arc by radius. So this is the formula we should have. In next video, we'll continue with this.